These videos are designed to approach the equation E equals mc squared, approach it from a new perspective. Rather unorthodox, but I believe it will stand on its own merits as explanatory. If we understand the principles that I'm going to express here, being able to apply them toward physics inquiry and toward understanding more distinctly, or even in a solidified way, in a reconciliation type of way, not necessarily the equivalency of energy and mass as expressed in the Einstein equation. I don't really feel that equation appropriately defines an equivalency between energy and mass. I believe that it expresses a relativity, and therefore if there's a relativity between one thing and the other, then there is a separation, there is a difference. That's the reason why we refer to energy as taking on the form of mass, or with a kind of a clumsy paraphrase there. But I believe that the equation equals mc squared, as well as all physics study up to this point, has kind of geared themselves toward viewing the problem as an equivalency, trying to discern an equivalency. And I believe that's kind of thrown physics progression off, science progression, mathematical progression off, because it's a predisposition. And that predisposition may or may not be correct. But I believe that what we need to focus on is the relationship, not the equivalency necessarily, but the relationship between energy and mass. The connection, the affinity, but rather still two separate forms expressed different ways. And what we need to focus on is what causes that expression to take place. What causes that relationship, that relativity. And if we understand what causes that relativity, then maybe we'll start to gain principles, start to come to more to understand how that relativity is birthed, and how that relativity really molds every action, every reaction, every process, whether it's from a macro level, macro systems, or even down to the quantum level. There's a relationship there that really hasn't been defined at this point. So we need to work on the relationship between one point and the other point of a string. We could refer to it as a string. You've got one vector, one stratum, one point of the string, side A, the other point, side B. And we look at these as equivalent. That is, the exact thing that's happening at A is happening at B. While that is happening, we need to come to understand why that's happening, and does it really express an equivalency, or does it reflect a relationship, a relativity that causes all the interactions between energy and mass to occur? What's the relevance of it? How does it occur? And how can we discern one from the other, outside of just one we can see, the other we can't necessarily see without instrumentation and things like that. So you have two sides of a string, side A, side B. Now if you can imagine that point A really exists in space at an infinitesimal spot. So if you have side A, side B, and you've got a line in between, a length progression, or a linear measurement there, then A exists not necessarily solely, individually, or as separate from mass, doesn't necessarily exist across that line. It exists at a point. And that point is established not only where itself is, but established relative to the other side of the string. So what we need to understand is, if side A exists at that initial point of the side A of the string, and B exists at the farthest end of that string, then what we need to be more focused on is the distance between these two. What's happening in the space between these two that creates that relativity. In other words, in order to get from A to B, in order to bring A or B together, you would have to contract that line. You would have to contract that line measurement until a certain point to where you could truly define an equivalence between one point and the other, because they would come together, mesh, and actually blend together to where you really couldn't distinguish one from the other. And in that sense, you may say that mass would disappear, or energy that we formerly didn't see appears or emerges. So we can consider this geometrically. We can consider it spatially. That side A, side B, so long as there's a distance between them, there is a defined relationship or relativity. And so long as that distance is there, the relativity in the relationship shows that there's one distinct form, another distinct form, and in some significant relevant way, they are different. They're not equivalent. The equivalency, so long as there's a distance measurement between one and the other, so long as that line link is there, they are not the same. They are expressions of one and the other. But if you draw that relationship, if you contract that relationship, remove the space between that relationship that's defining the relativity of energy to mass, if you contract that, bring it in toward themselves, then only when that distance is completely gone, completely used up, completely narrowed, can we see a equivalence between energy and mass. Add that line, then we see that there is an expression of two different energy forms nonetheless, but two different forms of energy or forms of mass that are separated and are relative at this point, are the same at this point. So E equals mc squared, I believe, defines more of a relationship, a relativity, versus a equivalency. Well, what causes the equivalency? What causes the former state of being separated yet related in some way that is yet really to be discerned? What really is the processes that's happening that causes a former state of duality, a former state of relativity, a former state of implied or suggested equivalence? What happens to create the ultimate point of relativity? I guess we could refer to it as a singularity, horizon, conversion. We won't get into that right now. But what is it that causes the space to stay that way, create the relativity in this sense, and what processes must occur to take the relativity of two forms separate from each other yet connected in some way? What processes occur to cause that relationship to be maintained? And then what process must happen to bring those two forms together to come to a state of real, true, absolute equivalency? So we'll discuss that in these series of videos. Primarily, we're going to start off with just a brief summation. Again, a rather unorthodox explanation of E equals mc squared. And I'm going to draw this out, illustrate it. Within my drawings is going to be suggested postulates, and some stated directly. And then after I demonstrate this as far as imagery and pictures and commentary, then I'll start to broaden the discussion out to show how just a simple illustration or picture that I'm going to draw, along with a brief explanation, we can continue to bring everything that physics knows or doesn't know, theorizes about, or believes is a very, very close approximation, or believes is an absolute reality. We're going to discuss all those. Physics inquiry, things that physics hasn't really got the grasp on yet. And we're going to use one simple, elegant principle, one lucid, clumsy equation, because I'm not really mathematically proficient. However, I do understand the things that's happened geometrically, because I've not just studied geometry, but I've been very aware of spatial relationships as existing within nature, and as always defined by relationship between what we can see, the mass limbs of a tree, and the geometry that's occurring between, from limb to limb, 360 degrees all the way around. There's geometric information that's found everywhere in nature. if we learn how to stop hyper-analyzing what we can see as if that explains everything, and really almost abandon this mass mentality, totally put it out of our mind, and then maybe we can be more resolved to understanding what we don't see necessarily. Dark energy, dark matter, things we know are there, that do exist. We haven't got a full understanding of what's happening, what processes, what phenomenal things are leading up to those things. But what there's geometry. Geometry, really, the relationship between any mass objects related to other mass objects, and is defined by the space around and within. Really, if we look at that and really pay attention to it and look at it from very unorthodox ways, inverting color, turning, manipulating an object, not as if, I'm not saying that everything is rotationally symmetric, but there's a strange type of rotational symmetry that's not even defined today, that no one that I've seen has really realized. It's not really defined the way they define rotation, but really every object that we see in mass, if you understand the principle, is an expression of rotational symmetry. And within that rotational symmetry is consistent geometric principles that one can follow to get more of an understanding of how energy is being projected, or how energy is being expressed as mass objects. But the energy is sending not just the ability for a mass object that we can see to emerge, but it's also sending information, spatial information. And the relativity between the mass and the surrounding space creates the big picture of geometry, the more relevant, the more full and qualified expressions of what's going on in the areas that we don't see or don't comprehend, which really comprise, as it concerns the physical universe, a great percentage of what we what all matter, mass, or energy that exists in the universe. So mainly my approach to understanding unified theory, understanding the way information is sent from one point to another, how information is disseminated, all of that, I believe, and from my own research and discovery, I believe can be explained completely, almost exclusively, in a geometric framework. But I would qualify that and say we have to understand the geometry as sharing a extreme, almost inseparable relationship to information. Information is found in every point in the universe, point A, and as expressed, point B. Whether point A is a small infinitesimal body of information that we cannot see, whenever it or however it is communicated to objects that we can see, that little space of information can be expanded through mass and explained through geometry, can be defined through geometry. So even though we can't read the information that's found in dark energy, dark matter, the dark void, the vacuum, or the void that is around us, that surrounds all mass objects, and I use that in surrounds objects. That in order to understand what I'm going to express geometrically, you have to understand that you have to appreciate that all the geometries that exist in nature, flora and fauna, all the geometries, if you take a geometric approach to looking out in space and seeing it seems like sporadic, just sprinkled, with no, we know that there's ordered systems, but when we look at it visually, it just looks like dots everywhere. But there are geometric relationships that are being expressed, whether you look at a small section of stars or whether you expand your view out to a large body of stars. There are geometric things happening. We can't just focus on a star and say that's a star, or here, that's a nebula, that's a galaxy. What we have to do is, while we're saying that, it's okay to say that, and it's true, we have to realize, well, wait a minute, that's a star, but wait a minute, there's a relationship, there's a distential relationship. And within distance, if you run a line this way, and with a distance, run a line this way, distance, run down this way, you're actually framing a geometric picture. And that's happening on the macro scale. It's happening in nature, and it's happening in a microscopic scale, and even down to the quantum level. Geometric principles relating to information as disseminated and sent, received throughout all of the universe, physical universe, and maybe even perhaps beyond, can be understood and read if we learn, organize, first of all, observe, come up with principles as far as what's happening in nature on either the surface value, the one-dimensional surface of a flower, of a insect, of a mountain, or whatever. Considering the surface geometry, then there's information that's on that surface geometry. And if we consider that surface geometry as actually horizon, the surface of everything that we see in nature, or the surface, or what we actually see, is really representative of a three-dimensional. In other words, the surface value of information is actually going deeper and deeper, and it's originating at a point. If you imagine a huge amount of information, whether it's compacted into a very dense, infinite point, or whether it's an expansive system, if you view everything as every object, everything, or every point in space, or every point on the surface of a mass, as really expressing the whole of information that exists all around us. But how do you come to understand that? And I believe the only way to do that is to geometrically seek patterns, geometrically devise a way, and of course I'll express how we can do that in nature in a very, very fascinating way. That if we learn to read the surface geometry, that the surface geometry is basically a preface, or the surface geometry is basically an informational point that has been either contracted or expanded to a seemingly other area of space. And if we learn how to take the surface geometry of a flower, which has geometric expressions on it, and expand it, what would the information that we can't see so much because the geometry is so small and so delicate, and so if we expanded the surface geometry of a shape, any shape in nature, and if we first of all accept that the surface geometry is expressing geometric principles, which is qualifying and bringing to light information that we really haven't learned how to read yet, and start expanding the mass object, expanding the smaller objects bigger, and expanding the bigger objects smaller, then maybe we can get a more broadened, more expansive understanding of how information is expressed at all points equally within, whether it's a fluid state of the universe or whether it's a static state of the universe. Or maybe when we get into what I'm going to show, we can show a reconciliation that a static state or a static system, a huge macro static like a universe, can exist within an infinite fluid space and never affect the fluidity, the smoothness of the fluid state. How can that happen? Imagine the surface of water. It's a fluid state. We drop a rock in it, it affects the fluid state, right? Creates waves, ripples. The rock goes down and deeper into the water, so it affects the fluid state so far down. So how can we reconcile the fact or the belief that we have a fluid, smooth universe, same at all points? How can we reconcile that to saying, but at the same time, there are static points within that. They exist, but they don't ever interfere with constants, interfere with consistent, and interfere with the smooth landscape as expressed everywhere. So how can you say that at this point it's both a fluid and a static state at the same time? Or at that point it's a static state within a fluid state, and we see no indication or evidence that the static waves or whatever is changing in any way the infinite system, which is smooth. That made any sense at all. We'll get into that. Illustrations and pictures tend to speak most certainly more eloquent than I am capable of speaking. I'm more of a, illustration type of person. I'm more of a person, if I want to understand something that has complex terminologies and jargon, i.e. mathematics, equations, then I try to approach it from a word standpoint, from a vocabulary standpoint. Try to translate every expression, every term, find the definition, and try to create a more lucid uh, abbreviation, and try to use words and the meaning of words to try to understand what's expressed mathematically or even geometrically or in other ways. So that's how I'm going to approach this. I'm going to try to show visually through imagery, illustrations, drawings that there, that we've kind of maintained this disposition and this staunch belief that there is an equivalency between energy and mass, when I believe what we really need to be looking at and understanding and seeking to define and comprehend is a relationship, the relativity. It's the relativity that really creates most of the problems in physics, is not a complete or an accurate understanding of what this phenomenon called relativity is. And actually the power of observation as seemingly having the ability to alter experiments, just the mere fact that you view them. And, you know, things like, you know, does mass really have weight? What is weight? All those things can be expressed in geometric ways, and I'm going to seek to do that. Long story short, let's get to it.